our biggest loser data set. It has a row for each person who is on the show and how much weight they lost, how much weight they started with, how much they lost. And that one here, delta, is weight loss during the time on the show. So we're going to take a look at this column K. Let's just start by getting some basic information. So we'll find the mean. This will be our X bar. That's going to be average. Okay, so I clicked it, hit Shift, Command, and down arrow to select all of the values. Okay, standard deviation we're going to do of the sample. So that's standard dev dot sample. Click, Shift, Command, down. And we need the count. That's how many observations we have. So to get a z-value, we will take the x bar minus mu divided by our standard deviation, which is s, divided by square root of n. Okay, so let's just do these in parts and it becomes really easy. We need a theorized mean. So we got 16. Let's see, what's the likelihood that it could have been 20. So our theoretical mean is 20. So we will take minus 20 divided by standard deviation divided by square root of count. And so we get a z-value of negative 7.49. It's negative 7.5. That value is larger than our critical value, which is 1.94. So it is highly unlikely that the true weight loss was 20. Right. We could just, now that we've typed in the formula, change this. What if true weight loss was 17? Okay, so that one we would fail to reject the null hypothesis. We can't really conclude if there's a difference between what we observed and this value. They're too close together. We could try 14. Oh, but 14 is too big or too far apart. Right, so it's definitely around 16. Right on the money. At 16. All right, so let's type in 20 again, and I'll just show how to do it. The same thing using XLSTAT. I've opened up XLSTAT parametric test, one sample. My column is going to be K for data. It has a label at the top, so I want that checked. I'm going to do a z-test. And under options, my theorized mean is 20. My level of significance is 5, so alpha equals 0.05. All right. So this is what it calculated for us. You'll see these are the same values that we did ourselves. So it's the same average and standard deviation. It gives us the point difference, which we calculated, but we didn't show. And our z-value. So if we go back to our data, we see that it's the same here and here. And this very helpfully tells us the null hypothesis is that the mean is equal to 0. The alternative hypothesis is that it's not equal to 0. And at the computed p-values lower than the significance level, we should reject the null hypothesis and conclude that there is evidence to suggest that the mean is not 20. There we go.